I always, for as long as I can remember, enjoyed lying down and staring up at the heavens and just ponder at how on earth did this wonderful universe come about.
That curiosity and a love of math and tinkering launched Jerry Nelson to the roof of the world, building some of the largest and most powerful telescopes on Earth. A modern telescope collects starlight through its mirror. Increasing the surface area allows it to collect more light and see dimmer and smaller objects. Since Galileo built his first 37mm telescope in 1609, telescopes were able to double in size every 50 years. But Nelson's telescope designs changed that dramatically. Nelson helped build his first telescope as an undergraduate student at Caltech in the 1960s. He earned his Ph.D. in high-energy physics at UC Berkeley. In 1972, he moved to Lawrence Berkeley National Laboratory, and then back to UC Berkeley as faculty. Nelson's interest in telescopes was rekindled when he joined a committee to build a new University of California telescope.
The world's largest telescope at that time was the Palomar, or 5-meter telescope. So I thought, we should try to do a 10-meter telescope. So the biggest telescopes in the world were all made with a single piece of glass.
But there are many problems, costs, and risks involved with casting very large single-piece mirrors. That was when Nelson had a brilliant idea.
The solution to that was to make it segmented, make it out of a bunch of small pieces. My associate sort of laughed at me.
The segments all need to work together to an accuracy of a few billionths of a meter, while moving to follow a star across the night sky. These hexagons at UC Santa Cruz, where Nelson is now a professor, are the same size as segments he made for the first segmented mirrored telescope ever built, the Keck on Mauna Kea in Hawaii. To support its 36 segments, Nelson borrowed a page from horse and buggy days. He designed wiffle trees under each segment, supports once used to distribute loads equally to a team of horses.
We built wiffle trees, tested them exhaustively.
But that was only one of many problems that Nelson solved to answer his critics. As the telescope turns, gravity moves the mirrors out of alignment. Nelson designed a set of sensors and an active control system to keep the mirrors in phase with each other.
The primary mirror segments for the Keck telescope need to be tipped and tilted, so the array of 36 segments acts like it's a single continuous mirror.
To act like one big mirror, each segment must be polished into part of a perfect hyperbola, a task that seemed nearly impossible. Nelson found a clever trick. Bend the mirror blank into the right shape, and then polish a simple sphere into it. When unbent, the polished segment bounces into the perfect shape. But perhaps the hardest problem is one that plagues all large telescopes. How do you take the twinkle out of starlight to sharply focus on dim objects? Nelson adapted a formerly classified military technology called
adaptive optics. It's another system which measures and corrects the aberrations introduced by our atmosphere.
The atmosphere is constantly churned with colder, denser air, slowing down light more than hotter, lighter air. The twinkle is the same for all neighboring bits of light. The Keck bounces a laser beam off the upper atmosphere to create an artificial guide star. Computers measure the guide star's twinkle and subtract that same twinkle from all its neighbors to resolve otherwise unseeable details. Since 1993, astronomers have used the Keck and its twin to test basic tenets of modern physics, creating stunning images of distant stars, measuring Einstein's relativity effects near black holes, and delving into the origins of the universe.
The ideas that people were so nervous about, with good reason, turned out were solvable problems. Our future should have these really giant telescopes.
Nelson is the chief scientist designing one of those really giant telescopes, the 30-meter telescope. Collecting 9 times more light than the Keck, the new telescope will take us back nearly to the beginning of time.
We didn't know all the answers to all the questions as we started. It wasn't that I read a book and knew how to do it. I learned how to do it because no one had ever done it before.
The 2012 Benjamin Franklin Medal in Electrical Engineering was presented to Jerry Nelson for his pioneering contributions to the development of segmented mirror telescopes.